Everyone, welcome to this video. So this is KCET 2018 and in this video I am going to solve question number 56 to question number 60. Right. So they have given this reaction. The appropriate reagent for the following transformation is, right. So here I have to convert this to this. What is the reagent I should add? So this is the question, right. So it is simple question. So you can see that the given molecule is this one. This is cyclic pentane ring, cyclopentane, which is having OH alcohol functional group, and here I have ketone functional group. So I want to convert this into alcohol should remain as it is only, OH, cyclopentane and alcohol remains as it is. Here it is C double bond O, CH3 was there. Now it becomes CH2, CH3. So from ketone, I need to convert into what? Alkane. Right, from ketone I need to convert what? Alkane. See, you can see that here. So here ketone functional group is converted to alkane, CH2. Right. So to do this ketone to alkane transformation, we have these reagents like this one, Clemenson's reduction, we call it as Zn, zinc amalgam, HCl. This we call it as Clemenson's reduction, which converts ketone to alkene. Other one is Wolff-Kishner reduction, in which we add hydrazine, NH2 in presence of KOH, and ethyl alcohol or ethanol. We will add it, right? CH2OH and CH2OH, right? So this reagent we call a Wolff-Kishner reagent. This is Wolff-Kishner reagent, and this is Clemenson's reduction. So other things, nickel and hydrogen we won't use. Sodium NaBH4 we won't use, because NaBH4 if we use, we'll get secondary alcohol. So this will be converted to secondary alcohol. So this is not the reagent. Nickel and hydrogen we won't use, right? So within these two, which one is the correct option? The answer for the given question is B1. Then question comes, why did you not use this A option, that is zinc amalgam and HCl, Clemenson's reduction? The reason is, see, here I have alcohol. So if I use this zinc amalgam and HCl, HCl is a strong acid, so it will take this OH and I may get alkene here. So elimination might happen. So because of this elimination might happen, we won't use this one. We only use what? Wolff-Kishner reagent, that is NH2 single bond NH2, KOH and ethylene glycol. So question number 56, answer is B. So now talking about question number 57. So this is the direct question from the chapter NCERT, direct question from the chapter aldehydes, ketones and carboxylic acid. Aldehyde, ketones and carboxylic acid. So this is simple reaction. Let me write it. So they have given toluene, right? Toluene is there. CH, H and HCH3 is there, right? Toluene I have written like this. As soon as this chromyl chloride, CrO2Cl2 in presence of carbon disulfide, this is simple solvent, this is chromyl chloride. It is a mild oxidizing agent, and I'll get a intermediate like CH, H. This H will be replaced by O, Cr, right? OH, and here one Cl, other Cl. Later on what happens, this bond will be broken, right? And this bond will be broken, and I'll get, and this bond will be broken like this. So later on I'll get, it is a mild oxidizing agent, so it converts toluene into carboxylic acid like this, CH double bond O, right? Other things remains as it is. So this Cl minus and this H plus will go as HCl, and this chromyl chloride remains as like this, CrCl and OH, right? So this is the product, we will get it, right? So we will get what? Aldehyde. What aldehyde? Benzene ring attached to aldehyde, we call it as benzaldehyde. So what is the option for the given question? That is B, or the second option, benzaldehyde, right? I hope this is the direct question from NCERT from the chapter aldehyde, ketones and carboxylic acid. Coming to the question number 58. The question number 58 is the reaction of benzene diazonium chloride. So many times we have seen, right? BDC, benzene diazonium chloride. This has been asked several times in NEET, JEE as well as in KCET. So this you have to remember. Reacts with aniline, right? It's yellow color dye, right? If it reacts with aniline, it gets yellow color dye. If it reacts with phenol, it leads orange colored dye, right? These things you will be studying in NCERT, right? Class 12th, right? How will you distinguish phenols and anilines? By BDC. BDC if reacts with aniline, it forms yellow dye. The same BDC if reacts with phenol, it forms orange dye, right? The name of the yellow dye is, right? Simple reaction. So BDC is what? BDC is nothing but benzene diazonium chloride. So this is benzene diazonium chloride. C. All right. So this is colorless liquid. Colorless liquid. To this, if I add aniline, aniline means what? Benzene ring will be there and NH2. So here, this since it is electron deficient, it acts as a electrophile. So since it is aniline is electron rich, it acts as a nucleophile. So what happens here? Benzene, this H will be replaced by this electrophile. So it does what? Electrophilic substitution reaction, and we'll get this product. Benzene ring will be remains as it is. N triple bond now becomes N double bond N, and at para position of aniline it reacts and will get this product. So this product we got it as what? Electrophilic substitution reaction. This is the electrophile, it is substituting this H, so we'll call it as electrophilic substitution reaction, right? Which will be yellow dye, right? So amino group para position is there, right? So the name of this yellow dye is para amino. So N double bond N we call it as azo compounds, right? N double bond N, azo, and here I have benzene, right? So the name of this yellow color dye is para amino azobenzene. So para amino azobenzene is the correct option for the given question number 58, that is B. Talking about question number 59. So this is from the chapter biomolecules, right? The glycosidic linkage involved in the glucose units in amylose of starch, right? In starch we have two types. Starch, it contains 20% of water soluble, and other 80% is water insoluble, right? This water soluble we call it as amylose, and water insoluble is amylopectin, right? So this is starch, and starch contains n number of alpha D glucose units only. Which unit? Alpha D glucose units only, because on hydrolysis it gives n number of alpha D glucose. So starch we call it as polysaccharide, right? So since it contains only alpha D glucose linkage, so here see beta is there, so we have to eliminate. So this is a wrong option, because we have only alpha D glucose, so beta we have to remove. So now we have confusion between B and D, right? So if you know the structure of amylose is what? It contains alpha D glucose having C1C4 linkage. C1C4 alpha linkage will be having. What is this C1C4 alpha linkage? Just you write it like this. See, it is very clear now. The structure of aminos will be like this. OH, the chain continues here. OH, H, OH, right? And here it will be H, CH2, OH, right? So here H will be there, here H will be there, and here OH will be there. Similarly, structure of this one is OH, H, and OH, and here H will be there, here H will be there, here CH2, OH, and here OH above. Since OH is above here, H will be like this. And here if I remove H, the chain continues here. Here also I have removed H and chain continues. So this is the structure of this is the structure of amylose, which is having, see, numbering always starts from 1, 2, 3, 4, and here also 1, 2, 3, 4. So it will be having 1, 4 alpha D glucose glycosidic bond, 1, 4 alpha glycosidic bond, right? So answer for the given question is 1, 4 alpha linkage is the present in what? Amylose. So this part is very important for JE also, right? You have to know the structure of all polysaccharides and their linkage. Whereas in amylopectin it will be having both linkage, C1C4 alpha linkage as well as C1C6 alpha linkage, right? So this thing also you have to concentrate, right? So coming to the last question of KCET 2018 chemistry, there you can see that the Ziegler-Natta catalyst is used to prepare. Right. Initially, once I have discussed about this in detail, but still. So see, this Ziegler-Natta catalyst is nothing but the titanium tetrachloride and triethyl aluminum. So this is the catalyst. What does it do? See, CH2 double bond CH2 is there, right? N number of ethylene molecule, if I take N number of ethylene molecule at pressure temperature catalyst, it does polymerization like this, right? Chain continues. But sometimes because of what radical mechanism, there might be some branching like this. Because of this branching between two polymers, these polymers cannot come near to each other. So we will lead to low density polythene. Low density polythene. To avoid this branching, we added this Ziegler-Natta catalyst. Ziegler-Natta catalyst, that is titanium tetrachloride and triethyl aluminum, because of which we only got the linear polythene bags. We only got the linear polythene. Since two polymers can be coming closer to each other, so the density will be high, because density is mass by volume. Since volume is less, mass is more, density will be what? More. So no branching, so they come very near to each other, so density will be high, so we will get what? High density polythene bags. Polythene, right? Polythene means number of CH2 single bonds like this, they form a polymer, so we call it as polythene bags. So answer for the given question 60 is C. We get high density polythene. I hope these videos are very helpful for you. If so, please share with your friends, to with your juniors, so that it will be helpful for them, so you can get good seats in engineering, medical, and your choices, right? So ICERs, right, basic science, IISCs, right? So it will be very helpful for you. So you have to support me, and I will make such videos, very useful, grateful videos on NEET, KCET, as well as GE, right? So thank you.